mentioned, originally I was going to have you look at graphs and create your own graphs, and I think I'm going to break that into 2 days. So what we're going to spend time doing today is analyzing graphs and how they function for polynomials, because this will be completely new for you, okay? And then I have 2 different activities we're going to do to assess how we're doing on analyzing graphs. So just a couple of things at the top, some definitions. When a polynomial is written as the product of its factors, which you guys have been doing this, when you solve, you get it down into what's called factored form, right? You're getting parentheses, and then when you get to the end, then you're solving that by setting those equal to 0, okay? So these are called the zeros or the roots. You're going to see zeros a lot. I'm also going to write roots because sometimes I might use the word roots. And just remember that that means that's the solution to our polynomial. And this part you've already done. You guys have already started practicing how to find the zeros, the roots, the solutions to a polynomial function. Okay? So just back to the basics. If I give you something in factored form, so this is already in factored form, what do we do to find the zeros of it? Yeah, set them all equal to 0. So let's just do that. So we know that one answer would be x equals 0. And then my other answer, I'm going to skip some work here, would be 1/2. And another answer would be 3. And my last answer would be -5. And so what you already know about solving, you guys can tell me then, what do you believe the degree would have been? If those are my answers, what do you think the degree would have been of that polynomial? 4, and how do you know? There's 4 solutions. And so what does that mean that what would happen on a graph? Very good. It would cross the x-axis 4 times, okay? Okay, so again, in the last unit, we found that the solutions of a function are the places where the graph crosses the x-axis. What's another name for those? Zeros, roots, what else? Think way back. Solutions crossing the x-axis is x-intercepts. They're also called x-intercepts. So where the graph crosses the x, again, everything you're saying is correct. Roots, solutions, zeros, these are all one and the same. So if I just give you a graph and I say, okay, find the zeros of this, what are we looking for? Where it crosses the x. Okay, so let's do the first one. You guys write on your paper what the zeros would be to that first graph. And one of them is kind of in between 2 integers, so just make up a decimal for that. And this is supposed to be a -4 right here. It got cut off. And can somebody tell me the zeros that you're getting for the first function? Aiden? -3, -1, 0, and 0.5. Who agrees? Is that what we're getting? Okay. So again, we're crossing at these spots. Good. Those are the solutions, the zeros, the x-intercepts, the roots. Yeah, Wiley? Okay, so when you're solving, you're always writing x equals a number, right? Because we know that that represents that point on the x-axis. All right, how about the next one? What would be my zeros of this function? Wiley? 2, whoa, hello. 2, 4, and 6. Okay. Now, before we move on, I want you guys to look at those 2 graphs because these are actual polynomials that are being graphed. And can somebody tell me, like, just a difference that you see in the 2 graphs? What's one difference? Barrett? Okay, first one crosses it 4 times, second one 3. Can somebody tell me what that might mean about these polynomials? Bailey? And so what do you think this one could be too? Okay, and what do you think this one could be too? Okay. Another difference, Maria. Did you say starts off? Is that what you said? What did you say? So you're saying this one is starting up in the positives? Down here? It doesn't start there because you read a graph left to right, but you're right. It does have, this would be a minimum. You're correct. That would actually be a minimum. And you're right. This would be a maximum here. What about that little one right there? What do you think that is? That's also going to be a max, so you're about to learn about this as we keep going. Anytime my graph changes direction, I'm going to have some mins and max. What do you think that one right there is? A min. How about over here? A min, okay. Wiley. Okay, so sometimes you're going to have like some highs and some lows that are very different. Tell me something else, and I want you to look more at the ends of the graph. Bailey. Change direction or, okay. Rhea, did you have something to add? Okay. Yep, good observation. Maria, sorry, hold on. Okay, and this is what I want to point out. This is going to happen where this one is in the positives on the left, it ends in the positives on the right. So it's going the same direction, okay? Now over here, it's not. Even though it's in the same quadrant, so you're going to see, this is a good observation. Sometimes they only go in 2 quadrants. Sometimes they spread out to all 4, but this one started in the negatives, and it ended in the positives. And you're going to see how there's going to be a pattern to this every single time. Yeah, Wiley. All of them would keep, yes. Yeah, probably. Yeah. These are going to keep going forever and ever and ever. Okay? Okay, so let's look at some of this end behavior that we were just looking at right there at the end. Okay? So if you have a highlighter, get it out. If you have a colored pen, get it out. So a lot of this is going to be information, but you need to be highlighting some of this so that you can easily look back to identify what we're talking about. Okay, so this whole table is what we call end behavior. And here's what that means. The end behavior is going to tell us what's happening on the leftmost side of the graph and the rightmost side of the graph, okay? And so here's what you're going to look at. You're going to look at 2 things to figure out left and right side. To figure out the right side, so leading coefficient is going to be right-hand side. And my leading coefficient is going to tell me what the right side of my graph is going to do. If my leading coefficient is positive, my graph is going to rise. If my coefficient is negative, my graph is going to fall. And we're going to use words like rise and fall, but we're also going to use words or symbols, I should say, like positive infinity and negative infinity. And that should make sense, right? If it's rising, it's going to positive infinity. If it's falling, we're going down to negative infinity, okay? Okay, so leading coefficient is going to tell you what the right-hand side will do. The degree of your polynomial is going to tell you what the left-hand side is going to do. The degree is going to tell us left-hand side, and here's how it works. If degree is even, it's going to do the same as the right-hand side, meaning If the right-hand side was positive infinity, the left-hand side will be positive infinity, like this. They're the same. They both went to the positives. That means it had to be an even degree. And what did we say it could have been a possible degree? We said 4, which is even. Okay? If it's an odd degree, it's going to do the opposite. Oh, sad. Why did that, go away? I don't understand. Let's try something. Huh. There it is. Okay. And if it is odd, it's going to do the opposite of the right-hand side. Like that first picture, where one side went up and rose to the positive and one side went down into the negative. Okay, so here's what we're going to do in this example. I'm just going to give you the polynomial, and I want you to describe for me the end behavior of this polynomial. So we're going to write it like this. So you can just say, okay, tell me what the right-hand side is doing, and tell me what the left-hand side is doing. And I almost always start with the right because the left is based on what the right did. So right-hand side is leading coefficient. So what is our leading coefficient in this case? A 4. It's positive. So what does that mean right is approaching? Positive infinity. Or you could say rise. Is this an even or odd degree? It's odd. So left-hand side, is it doing the same or is it doing the opposite? Opposite. So that's going to be negative infinity, or you could say full. Okay, let's look at the second one. Right-hand side goes with leading coefficient. What's the leading coefficient? -2. What does that mean it will do? Good. It's going to go negative. It's going to fall. Even or odd degree? Even degree. So what does it do? It does the same as the right, so it's going to also go to negative. Okay? And again, you're going to want to reference this until you get it memorized. Okay? And find a way for you to memorize it. So I try to think of it as like if leading coefficient is always the beginning, if the leading coefficient is positive, I go positive. If leading coefficient is negative, I go negative. And then figure out how you want to memorize your degree one. Okay? All right, so now, just like we just saw in those first two pictures, you guys were saying how it was kind of taking multiple turns, right? And those multiple turns are what we call these turning points. So a turning point is where your graph is going to change direction. And we know when we learned about quadratics and parabolas, where the graph changed direction was actually called the vertex. In a parabola, it's a vertex. And so we found out in quadratics that vertices could be maxes or mins. The same is true for polynomials. We're going to have maxes and mins. The difference is that there can be two types of maxes and mins. So there can be maxes and mins that are relative, meaning they're just a high or a low point in their area, or they can be absolute. If they're the highest or lowest it will ever reach. And so I'm going to highlight those words. Relative, absolute. So absolute means it's the absolute highest point or lowest point. Relative would just mean they're a turning point. They're a high and a low, but they're not the absolute highest or absolute lowest. So if you go back to that front page, just to reference this, and you guys had already noticed some maxes and mins. So tell me, would this minimum right here on the right-hand side, would that be a relative min or the absolute min? That's relative. What about that max? Relative, because it's going on and on forever. What about that min? Good. That is the absolute lowest that function can go. That would be absolute. Okay? Now, hint, if it's going in opposite directions, will your min or max ever be absolute? Never. It will always be relative because it's going to go on forever in both ways. Yeah. This one? Nope. Why is it relative? Yeah, both sides of the graph are continuing to go past that value right there, right? So it'd just be relative. Okay? All right. So, last thing, which I just alluded to, were your turning points. And here's how you know how to find how many times your graph might turn, is this formula right here. This n minus 1, where n is the degree of your function. Okay? So, for example, this example 4, the graph of y equals 2x cubed minus 5x squared plus 3x plus 3 would have at most, what's the most amount of times that it could turn? 2 times. And how do we know that? It's the degree minus 1. Just that formula, n minus 1. Yep. Okay, so that's a good question. Is a turning point a solution? Could it be a solution? Yeah, it could be a solution, but it doesn't mean it is. Now, here's what I want us to make sure we understand. This is as many times as it could turn. So that means my graph, like if I said to sketch it. Okay, couple things. It's a leading coefficient that's positive. So what would the right side be doing? Okay, the right side would be a positive infinity. That's an odd degree. What would the left side be doing? Opposite, which would be negative infinity. How many solutions could I have? Solutions, or zeros. I could have 3 zeros. Doesn't mean I will, but I could, right? So let's just pretend. And you're going to see how this works. So I have to be up here in positive infinity to the very right. Then I'm going to drop. I'm going to cross. I have to finish in negative infinity. Did that turn 2 times? It did. Okay? Now, if I get out 3 zeros, do they all have to be real numbers? What can your answers be? They could be imaginary. So let's just say I got out 2 real and 1 imaginary. Do imaginary answers live on the x-axis? They do not. So how many times would this one cross the x? Oh, I wanted to change that. Sorry, that doesn't make sense. Let's say 1 real, 2 imaginary. So now, how many times would it cross the real? 1, or the x-axis 1. So let's just say it was 0. Okay, so if this was the case, I have to live up in the positives here. Where do I have to live on the left side? In the negatives. How many turning points does that have in blue? So remember, a turning point means the graph changed direction. 0. 0 turning points. Okay? So here's the deal. When you're identifying turning points, the absolute most that you can have is n minus 1. And then after that, you subtract 2 every time, and that's how many it could have. So it could have 2, or it could have 0. And it's important that you recognize that, because your graph, if it has imaginary solutions, is not going to turn the most times that it could. Yes? Yep. Nope. So the leading coefficient is positive. So the right side would be positive. Yeah, I do right and left like this. Right, left. Is that how you do right and left? Okay, just making sure. Just making sure we're on the same page. Okay. Okay, so the most turning points is n minus 1, but you can always take away from that. You got to take it away in groups of 2, though. They can't just drop by 1. That doesn't make any sense. For it to work, your end behavior only works if you subtract 2 every time from your turning points. Okay? All right, so let's try this. So we're just going to break this down to start. So we're going to start here and we're going to find these zeros. Oh, my heaven's sakes. So how do we find the zeros of this function in factored form? Yep, set them equal to 0. Okay, so here are my zeros. Okay, and then we're going to sketch a graph. So before we start, what do you automatically know is going to be on your graph? Yeah, all of those are x-intercepts, right? Because that's where it's going to cross the x-axis. So we're going to put 1 at -1, at +1, and at -3. Now, I need to know end behavior to be able to sketch this graph, okay? And again, this is called a sketch for a reason. It's going to be very generic. So what I do know is that my function looks like this, right? There was my function in factored form. And so to be able to determine end behavior, I've got to know my first term. So how could I, if I'm in factored form, figure out my first term? Wiley? Yeah, just multiply all your first terms together. So what do you get when you take x times x times x? X cubed. Okay. So from there, I know what's happening on the right-hand side of my function, right? Is my leading coefficient positive or negative? Positive. So what's my right hand going to do? Positive infinity. Left side, odd or even degree? Odd. So what does it do? Opposite. So that's negative infinity. And then this is all you're doing. Okay? Is everybody ready? I'm going to the very point on the very right of the graph. And my function needs to end how? To the right of this. Up. So I'm going to go up. Draw an arrow. And it's got to cross the x-axis, right? So I'm going to cross. I've got to cross again. I'm going to cross again. How do I need to be ending over here? And I will. And that's my function. So we do not care what's happening in the in-between. This is a sketch. We're not plugging in points. If you know your real solutions or your zeros, put them on your graph, get your end behavior, you're done. Okay? It's just a sketch. Now, let's list the relative mins and max. How many are there? How many mins and max are there? There are 2. Are they absolute? They're relative, right? They're relative. So let's go ahead and mark it. So we know that that's a relative max, and we know that that's a relative min. How many turning points are there? There are 2 turning points, right? Which I'm going to write it like this. Because if there's a min and a max, there's a turning point. The mins and the maxes are the turning points, right? It's where it's changing direction. There could have been at most 2 turning points. However, I can't find words. What's the other option you could have had for turning points on this one? 2 or 0. We could have had no turning points if we would have gotten some imaginary solutions. Yes, always by 2. Otherwise, it won't end correctly, your end behavior. Okay. Now, this is important, and you got this on your quiz today. Okay? You got this answer. And here's what it is. When the same 0, that's an intercept, occurs multiple times, the 0 is said to have multiplicity, meaning It occurred multiple times. Everybody with me? So that would be like you get out x equals 2, x equals 2. That's an example of a zero, meaning solution, that has multiplicity. Okay? Here's how it works. If the zero has an even multiplicity, even, that's key word here, meaning it comes out, you get that answer 2 times or 4 times or 6 times, then your graph will bounce. There's the key word. Bounce off the x-axis. It will not cross. Normally you would cross there. You're not going to do that. You're going to bounce off. If it has odd multiplicity, so you get it out 1 time, you get it out 3 times, you get it out 5 times, then your graph's going to do like it always does. It's just going to cross, just like normal, which makes sense because every time you get out x equals just 1 or x equals 5 or x equals 2 or x equals 4, we cross the x-axis at that point. Okay? And we're going to do an example where you're going to watch this bounce. So let's go ahead and solve. What would be all my zeros for this function up here? -2, -2, -3, and 1. Okay. So you're going to put that on your graph. So I'm going to put -2, -3, and 1. Okay, let's write down what this function was. We got to figure out end behavior. How can I figure out my first term? Multiply it. Yep. What is happening? Okay. So when you multiply all of that, what do you get? X to the 4th. All right. So right-hand side will do what? Good. It's a positive leading coefficient, so it'll go to positive. What will left-hand side do? Good. It's going to be the same because it's an even degree. It's going to follow. Okay. Now I want you to just watch me for a second. Don't do this. Okay, so here's what I would do. I'm going to go to the right point, and I'm going to be up here in positive infinity, right? Now I want to show you, if you don't bounce, you're going to tell me why this is wrong, okay? So here we go. So I would cross, and then I would cross, and then I would cross. If that's what we did, tell me why that's wrong. Yes. Yeah. So this is what kind of a degree if it's in opposite directions? It's an odd degree. And what did we know that it is? It's an even degree, and we also got out 4 solutions. So that doesn't make sense. So what happens here is I get to here, and I bounce back up. So if it has a multiplicity that's even, you bounce off that intercept, and you go back up. And now, is it both ending in the positives? Oh, I think I did that wrong. I have it crossing at the wrong spot. Hold on a second. What are my numbers? -2 and -3? So it's supposed to bounce at -2, right? Okay. So it would bounce here and then come back through. There we go. That's more like it. Sorry about that. Now, how many mins and maxes do we have? 3. Where are you missing one? Yes. So I have mins here. And I have a max here. Any of those look like absolutes to you? Yeah, one of the mins could be, right? We don't really know at this point because we're not plugging in points to see which one is right. But if you got a graph that was already done for you and you were asked, if that's the absolute lowest, then you know that's an absolute. Okay? All right, anything there? Okay, so here's the last thing. We're going to take each of these graphs and we're going to answer the following questions. So we're going to label these. Let's label them 1, 2, and so on so that we can make sure this is correct. Okay, so let's start with the first graph. So question 1 says, is the degree of the function even or odd? Lucy? Yep, they're going in the same direction, so we know that that's always even. Question 2, is the leading coefficient positive or negative? Maria, how do you know? Where? On the right-hand side, it is going down. Good. That means it's negative. Number 3, what is the possible degree? Now, has to be even. You got to pick something that's even. How can I figure out what the possible degree could be? What am I looking at? Wiley? Okay, how many times it crosses the x-axis? So let's go up here. I know I'm crossing here, except I'm not crossing there. I'm crossing here. I'm crossing here. Now, how many points do I have up there? I have 3. Can it be a degree of 3? What are we missing? Wiley? So what does it mean? Happened how many times? Twice or 4 times? Or has to be an even number, but we know it bounced right there. So that value had to have come out at least twice, right? At least twice. So this is why you can't just declare it definitely was twice, because we don't know for sure. That's why we're saying what's a possible degree, not the actual answer. So what could be the possible degree then if it happened 2 times? A 4, degree of 4. What if it would have happened 4 times? 6, and you could just continue in that way. Okay, so there could be multiple answers to this one. All right, domain. Is there any limit to how wide this baby can go? Nope. So what's your domain? Negative infinity to infinity, or what's another way you could say it? All reals, which I'm going to write the all real symbol just so we can practice doing both. Is there any limit to the range? Any limit down below? So we know it's starting at negative infinity. Any limit to how high? What is the limit? I would say 4, yep. And that's closed, correct? Okay. And the last thing you're doing is stating max and mins and telling me are they relative or absolute. Now, one thing, when you tell me a max and min and you tell me the value, you're telling me the y value, okay? So mark on your paper where you see maxes and mins. And somebody tell me, is there a max or a min right there at 2? How do you know there isn't? It doesn't change direction. So I'm going up, up, up. I'm flattening a little bit, but I'm still increasing. So that would not be a max or a min, okay? So let's start over here at negative 1. That point at negative 1. Is that a max or a min? Max. And you're telling me the y value. What's the y value right there? So it's a max at 0. Is it relative or absolute? Relative. Now I'm going to go to this point. Is that a max or a min? Min. At what value? Negative 4. You're always telling me y value. Is that a relative or an absolute? Relative. And then my last one, I'm going here. Max or min? Max at what value? 4. Absolute or relative? Very good. That's absolute. Oh, that is a negative. What am I doing? Oh. Okay. All right, I want you to try the last one on your own, and then look up here, and we're going to check answers. All right, let's look up at the first three. You should have said degree has to be odd. Who said odd? Did we get that right? Should have said a negative leading coefficient. Did we get that right on number 2, negative? Possible degree, 3. You could have said, what else? 5. How could 5 be the degree? Like, I only see it crossing 3 times, but what else could be happening? Say that again? I don't think there's a bounce. What else could happen, though, for your solutions? I could get 2 imaginary answers, right? And so the 2 wouldn't cross the x-axis, but the 3 reals would. Okay, so 3 would be correct, 5 would be correct. You could have said 7. Domain, you should have said all real. Do we get that? It goes on and on, wide. Range, is there any limit? Nope, that's also all real. Okay, let's check max and min, which I might have need a little help, you guys, seeing these values here. First, if they're going in opposite directions, are any of these absolute maxes and mins? They're all relative, so you should have done all relatives. So this is a min at, did you guys say -7? Okay, that's relative. That's a max at, did you say 5? 5, 4, whatever. I don't know. I can't see. I'm going to say 5. I don't care. If you said 4.5, if you said 4, that's close enough. And then another max at 6 on this one. And again, that one is also relative. Okay? Does anybody have any questions? Here. Yeah, Julia. It is. So that's a min. Thank you. At 2 or 2.5. Yep, thank you. That is a min. There's 4. Now, let's think for 1 second here. How many turning points do you see? 4 turning points. So, what does the degree have to be? Degree has to be 5, right? Because it turned at the most 4 times. Now, does it have to turn 5 times? It doesn't, right? So could the degree be 3? Yes, it could. So keep that in mind. 5 would make more sense in this picture, but I would count 3 if you put 3. But pay attention to your turning points. Okay, so here's the plan. There is a Canvas assignment on Canvas that you're going to do. I also have a Desmos activity. We're going to wait and do that next time because it's important that I want to be kind of a part of that with you as we're working on that so that we're really understanding graphs. So next time, we're going to start off class doing the Desmos activity. Then we will work on creating our own graphs, doing 5-4, and then you'll have an assignment based off of that. Okay? So Canvas only. Yep, Canvas only is your only assignment for tonight.